Hey guys, Dude Legit City here. Today we're going to be going over some Oxygen Not Included basics. Today we're going to be going over power. And of course, to get it started, we're going to be talking about the power generators. You guys could go into the power tab, look at the generators by the name, and you guys could tell whether or not it is a generator by looking at the effects tab. Each generator is going to provide power on a positive number in watts, and that's always going to be per second, meaning that our manual gen right here provides 400 watts per second as long as the duplicate is running on it. That being said, all generators have this feature of having in the effects tab a positive value in watts for the per second value of power they generate. Now, of course, that means that the power consumers is going to be on the other side of the tree. It's going to be on the requirements tab. Any building that requires power to operate is going to have power in the requirements, and the wattage over here is, of course, going to be per second, depending on if the building is going to be constantly running or not. And you're going to be able to find that by clicking on a building, going to properties, and looking at the uptime. The uptime of the building is a percentage value of how much power or how active it was during the cycle, either the current cycle, last cycle, or the average over the last 5. This is a great indicator to see how much power that building is going to be drawing, because although the amount of power it can consume is going to be 240 watts, it has not actually consumed any power yet, so the uptime is at 0. However, there are some buildings that are constantly on, like let's say the furniture, the ceiling light, as the light will always be on as long as there's power. And by looking at that, you'll see whether or not it is going to be a constant consumer or only going to consume when it's active. That being said, how do you provide power from a generator to a building? And the answer to that is going to be using your wires. The wires right here, you could see that we ran a regular wire through the floor so that we could hide it, make it a little bit cleaner looking for our duplicates, and while hiding the decor. Now, the wire is going to be how we provide power to said building. However, the moment Geek over here gets off of the wheel, although the micro musher is okay to be used, the moment they run off, we're going to get a debuff saying no power. When there's no power, the building is going to lose all its functions and, of course, not operate. So in order for us to get past that, we're going to need what's called a battery. The battery is going to act as a buffer as long as we have it on the same line. It does not matter whether it's before, after, as long as it's on the same power line, we're going to be able to store all the extra energy that's not being consumed so that when there's no one running on the wheel or no resources being burnt off on the generators, we're going to be able to provide power still. Now down here we have a set of generators running into a regular battery. We are charging up the battery while powering the ceiling lights, and any extra power goes to the said battery, and once it's topped off, the duplicates stop running. Although this is a very attractive feature so that your buildings always have power, the issue with batteries is that they have something called power leak, also known as runoff. Every cycle, a certain portion of power, as long as your battery has power, is going to leak out, meaning that you're basically decaying the power and it's not perfect storage. Not only that, it also generates heat. The battery charge will be lost as heat. And with that, the fact that the game is going to become a heat management game later on so that you can maintain certain states of the elements, you're going to be wanting to not have as much heat as you can, as it will slowly influence the environment. So because of such, typically we will gravitate towards using batteries in the beginning. However, once we get refined metal to use smart batteries, it is always more beneficial as you lose fewer resources to have the smart battery automate your generators so that your generators only provide power when it's needed. That's very simple with the automation input of the smart battery. Usually it's just a direct plug and you control the values on the smart battery, but we are not going to be getting too deep into that. If you guys want to see a video, we'll leave a link to a smart battery automation video down below. And if you guys are curious, you guys could check that out. Now, that being said, with the power, there are a couple differences between our wires and our variety of options that we have at our fingertips. As you can see right here, we have 4 sets of power wires and 4 sets of bridges. That's because each wire has a different upper limit and different resource requirement required to actually build it. A regular wire, which is the cheapest, using metal ores and not refined metal, is able to go through tiles, however, only provides a maximum wattage of 1000, meaning that if we go over the 1000 watts, we're going to have something called overloading. And we'll show you right now how overloading occurs. So as you can see right here, we have 3 people running on the generators. If we were to look at this, each generator provides 400 watts of power. Not only that, our current wire only holds 1000. As you can see, it's glowing red, telling us that there is an issue with this. What it's telling us is that our wires are being overloaded currently and it will start to break. And we'll see that just right now. As we let the duplicates run, we're going to see something called overload damage. Eventually, after the bar goes down to 0, it's going to completely break the wire, severing the connection between the generators to the transformer. The location of where the damage occurs is random, and this happens because this entire line that's connected right now has a chance of having the damage come up at anywhere along the line, and it's because although this transformer is able to pull up to 4000 watts, we're only providing 1200. However, that is 200 above how much the wire is able to handle, causing the wire to require repairs. This is not something you want to do a lot, as repairs do use up your resources, so a lot of the times you want to avoid doing so. Not only that, in the beginning of the game, you're going to be reluctant to waste metal ore, as that's going to be the major bottleneck in a lot of cases for you to get refined metal and or anything beyond that. So when you have the watch limits seen over here, this means that you should choose the correct wire depending on what you're trying to do. And we'll show you how to choose the correct wire for the situation. The biggest thing to usually look at is your generators. If your generators are able to actually charge the battery that should be in line with the generators, you want to add up cumulatively how much wattage that is. You could see right here with 3 manual gens, this is 1200 watts. And even though it's safe at 2 people running the wheel, the moment the 3rd person runs, we'll start to see damage again. And because of that, we are actually better off using the conductive wire that's topped off at 2000 watts. This conductive wire allows us to safely use the generators to feed into the transformers, and it will not cause damage. A lot of the times, depending on what you have on this side of the line, you want to make sure that your generators are able to actually safely transfer power to your battery or your other buildings, and because of that, the generators are going to be the first thing you guys check out. Always have a wire that could hold the charge of all generators running at the same time. Next thing to look at is going to be your power wire in and of itself. If you attach too many consumers, let's say that I added 6 micro mushers and they were all on connected on this power line, it would actually tell me I had 1440 watts of power on this. And even if I was able to buffer it with a battery, I will actually start overloading if they all pull power at the same time. It's going to ask the battery to provide power for each building, and the battery is not going to know if it's overloaded or not. So it will provide power to each building if I did have 6 micro mushers, which will overdraw the power, causing it to start overloading, as we see down here. A lot of the times, you want to make sure that your wire can handle the potential load. However, if you are a more advanced player and you do know how the uptime of buildings affect everything, you guys can go over the threshold if you can safely manage all your power consumers not actually turning on at the same time. Of course, that's going to be for more advanced players, more experienced players. I would recommend for newer players to just try to have the potential load within the range of your wire. Now, the next thing we have are going to be power transformers. Power transformers are going to be pivotal for you to distribute power in your colony, and the reason being is because power transformers allow you to safely convert from a heavier wire down to a weaker one. The power transformers, what they actually do is they act as a miniature battery, pulling the amount of power coming from a battery or generators and storing it on the transformer itself. Not only that, it actually acts as a one-way for power, if that makes sense. We take the larger line here, feed it into the top, which is going to be the feed into the transformer, and then on the feed out, we create a new line that's going to be separate from the existing line. This is actually very good, as you're not able to actually have a mixed line without damaging the weakest part of the line, kind of like the weakest part of a chain will become broken if enough force or resistance is put onto it. Same thing happens with the power line. The weakest part of a power line, especially if you have a mixed wire with segments of a regular wire, conductive, heavy watt, or heavy watt conductive, if you mix them up, the weakest part of it will typically be damaged first. Now, with that being said, one of the things you guys want to avoid is, of course, a mixed wire. If you guys do have segments of wire that are different segments and they're all connected, that is always going to be a bad decision, as you are only as strong as your weakest link. In our case with power wires, if you had a 100-foot cable of heavy watt conductive wire, that one segment of regular wire is going to cause overload issues. Now, of course, if you have replaced your entire line with it and you're within the range of the power being provided and you're wondering why you're still having issues, one of the biggest problems that happens a lot of the times is when you're replacing the wire segment on the actual input right here does not get replaced. Especially when you're zoomed out, you may not notice that. That usually is the biggest cause for broken wires, and if it does happen, you guys could try to run over all your wires like so. And if you guys have a build command, you are replacing a different wire type. If you don't have a build command like I just did, then you're perfectly safe. But you do want to avoid mixed wires when you can. If you do want to provide power and spread it out, the best thing to do is using your transformer. And if you guys didn't know, when your generators are running, you actually provide power evenly to all buildings regardless of how much power is already on it. Of course, if it's full, it does not consume any of the power. That means if you have a smart battery and a bunch of jumbo batteries behind it, they're almost always only going to charge up to around 20,000 watts, meaning your jumbo batteries are never going to get topped off due to the fact that they have a wider capacity than the smart battery. However, the smart battery is what actually controls the generators. Now, because of this, you could safely use a transformer to change your wire so that, if you didn't know, the heavy watt wire and the heavy watt conductive wire right here cannot go through tiles, and because of such, you may want to use the heavy watt or heavy conductive watt for your immediate generator location connected to your smart battery and transformers before providing power to the rest of the base. An example would be something like this. We have a smart battery right here connected with a heavy watt conductive wire to my natural gas generators, and then the same wire goes into the transformers. We have these same wires feed into each and every transformer, and then after that, we have each transformer become a conductive wire that goes through the tiles. This is going to be typically similar to how you will normally provide power to your base, and as such, you will be looking for something a design like this. Although you don't have to use conductive wires, you guys could also use the smaller transformer and use the small wire as well, and whatever the situation calls for, you'll be able to provide for it. Of course, another thing about this is that the overloads for these wires, because the transformer effectively creates a new line with that, are separated. This is very key, as that means that this line, if it does overload, it will not overload the other line. However, if this does overload and break, the transformer does lose power. On the vice versa side, if this wire overloads, the main line feeding into the transformer is actually still safe. So because of that, you don't have to worry about overloading issues. And if you guys are looking for what's causing the overload, that's something to check out. But guys, that has been the power basics in the game of Voxel Not Included. If you guys have any questions, leave a comment down below. Hope you guys enjoyed today's video. And of course, guys, don't forget to like and subscribe. Thank you, guys.